right, welcome to 5.2, graphing linear relations. And so this is what we're going to do today. All right, we are just going to, we've done graphing before. We've done graphing a couple of different ways. I'm going to introduce another way of graphing over and above what we did before. But there are, so we've done graphing before using a table of values. We've done graphing before using the intercepts. That's an option in this as well. So to find the x-intercept, you let y equals 0. To find the y-intercept, you let x equals 0. That is definitely an option in analytic geometry, and we will be using that at some point. I'm also going to do it a third way. So these first two, it says graph using a table of values. So let's just take a look at these words up here. So a straight line can be drawn through any 2 points. When constructing a table of values to graph a line, use at least 3 points just to make sure that they all line up and you've done your math correctly. You can pick any values you want independently for that independent variable of x. So this time there is an independent and a dependent. X is always the independent and y is always the dependent. And choose your x values wisely. So sometimes it makes more sense to choose some values than others, just so that you don't have to deal with fractions. So this first one, pretty easy. For your x and your y, I would choose at least one negative x value and at least one positive x value. And then maybe also choose 0, because 0 is an easy one. So normally what I do is -1, 0, 1, normally. So then the y value, you're going to substitute -1 in for x in this equation. So -2 times -1 plus 5, that equals 2 plus 5, which equals 7. This is going to be -2 times 0 plus 5, which is going to equal 5. And then this is -2 times 1 plus 5, which equals 3. Notice there is a pattern, and there should be. So -1, 7. So I'm just going to go 2, -2, 2, and -2, just to give myself some scale. So -1 is here, 2, 4, 6, 7 is up here, that's 7. So -1, 7 is right there. 0, 5 is right there. 1, 3 is right there. Those sure look like they're on a straight line. So that must be my line right there. There we go. We're done. That's it. That's all there is to graphing by table of values. You just pick values for x and then plot them. For this next one, though, remember this up here says choose your x values wisely. So you want to think about what kind of x values can you choose to make this maybe a little bit easier for calculations. And so take a look at your denominator, and what you want to be able to do is maybe cancel out that denominator so you're just dealing with whole numbers. So I'm going to choose -2 as one of my values. So 3/2 times -2, the 2 and the 2 will cancel, -4. So then that just becomes -3, because that negative is still there. -3 minus 4, which equals -7. Then I'm going to choose 0. 3/2 times 0 minus 4. That equals -4. And then I'm going to choose 2. 3/2 times 2. The 2's will cancel. -4. That gives you 3 minus 4, which equals -1. Again, there's a pattern. You should see a pattern in your x's. Sorry, in your y's. As long as there's a pattern in your x's, you'll see a pattern in your y's. Okay, so -2, -7, this is -2, -4, -6, -8. So that's going to be right here. -2 is my x, -7 is my y. 0 and -4 is right here. 2 and -1, that's 2 there. -1 is right there. Those sure look like they're on a straight line, so I think I'm good. Okay, there we go. Beautiful. All right, so that's graphing. Oh, here we go. Here's another one. All right, this time I want to choose x values so that my numerator is going to be divisible by 3. So 7 minus 4 is equal to 3. So to get this to be equal to 4, I need x to be equal to 2. So I'm going to put a 2 here. So 7 minus 2 times 2 over 3 is 7 minus 4 over 3, which is 3 over 3, which equals 1. I don't want to use 0 this time because 7 minus 0 is equal to 7, and then I've got to graph 7/3, and I don't want to have to do that. So maybe if I use 5? What if I use 5? Let's see. 7 minus 2 times 5 over 3 is 7 minus 10 over 3, which is negative 3 over 3, which equals negative 1. So 2, 1 is right here. 2, 1. 5, negative 1. 2, 5 is here, and negative 1 is there. So there's 5, negative 1. Now I want to choose another one. I'm going to go to negative 1. Like, these x's don't have to be in any particular order. So 7 minus 2 times negative 1 over 3 equals 7 plus 2 over 3, which is 9 over 3, which gives us 3. So at negative 1, this is negative 1 here, we're up at 1, 2, 3. Okay, those are all on the same line. Didn't do a very good job of that line. There, that's better. Okay, and when you do lines, when you graph lines, notice how my lines are going beyond my points. I'm not just going from the first point to the last point. They go through all of the points and beyond, and that's what I want to see. I also want to see arrows on the ends. Okay, so I will take marks off. Not that it matters right now because you're not losing marks anyway. But you won't gain marks if you make mistakes. So lines go beyond the points and there's arrows on the end. Okay, method number 2 is what we call the slope y-intercept method. So remember when we had y equals mx plus b before? M was our croc, but now we're calling it the slope. And b we called the starting value. Well, that starting value is the starting value on the y-axis, and we talked about a point on an axis is called an intercept. So this is actually in analytic geometry, we don't call it the starting value anymore. We now call it the y-intercept. Okay, so in y equals mx plus b, m is the constant rate of change or slope, b is the starting value or y-intercept, which is where the line starts or where the line crosses the y-axis. So for this first question, this is going to be the slope, negative 5/3, and the y-intercept, actually I don't want to write it like that. Let me erase that. So the slope equals negative 5/3. The y-intercept is equal to 2. So I go to my graph. Step 1. This is step 1. Plot the y-intercept on the graph. So the y-intercept is 2. There's 2 on the y-axis. Then from there it says step 2. Count squares up or down, then left or right, according to the rise and run of your slope. So if the slope is negative 5/3, negative 5 is the rise, and 3 is the run. So from there, from this point at 2, I'm going to go down 5. So 1, 2, 3, 4, 5. Don't draw those little loop-de-loops when you're doing it, just count. I'm only drawing it so you can see what I'm doing. So I'm going down 5. Oops, I don't want to plot a point there. Take that point away. And then once I've gone down 5, from there I want to run 3. So 1, 2, 3. Plot a point. Okay, so rise is -5, run is 3. Now, -5 over 3 is also the same as 5 over -3. Like I said, that negative sign can go with the 5 or it can go with the 3. It just can't go with both. So this is the rise now. The rise is 5, but the run is -3. So again, from the y-intercept, I'm going to rise 5, 1, 2, 3, 4, 5, and then I'm going to run -3, which means run backwards 3, and there's another point. And then from either one of those points, you can do it again. Down 5, 1, 2, 3, 4, 5, run 3, 1, 2, 3, there's another point. Okay, don't draw the loop-de-loops, just count. So I'm going to erase all those loop-de-loops because I don't want them. I just want the points. We don't draw the loop-de-loops. Okay, now we're going to draw a line through all those points, beyond those points. Perfect. Okay, there we are. You just keep doing the slope over and over and over again. All right, let's take a look at the next one. Y equals 2x minus 5. The slope equals 2. You need a rise and a run, and the number 2 as a fraction is 2 over 1. And the y-intercept equals -5. So step number 1, plot the y-intercept. So 1, 2, 3, 4, that's down here at -5. 1, 2, 3, 4, I'm going to just label. I hate a graph that's not labeled at all, so I'm doing a really bad thing. I'm not demonstrating very well. You got to put something on your graph to show me what your scale is. Okay, slope is 2 over 1. So from the y-intercept, you start at the y-intercept, rise 2, so that's up 2, run 1. When we run, a positive run is a run to the right. So I'm going to go up 2, loop-de-loop, don't draw the loop-de-loops, and over 1, plot a point. Up 2, over 1, plot a point. Up 2, over 1, plot a point, and you can keep doing that. Just keep on going. And 2 over 1 is the same as -2 over -1. So we can go down 2 and backwards 1 and plot a point. Down 2 and backwards 1 and plot a point. Again, don't draw the loop-de-loops. You don't want those. All right. Draw a line through all these points, beyond the lines, and arrows on the end. And that's it. Okay, so the rest of it is your job to do. And I will post the solutions at some point. Ask questions if you have any.